Today we will be covering Chapter 1, Section 5, that is over inequalities. Our two topic objectives for today will be to use the symbols less than, greater than, and equal to correctly to compare two real numbers, and then to evaluate numbers and absolute values. So first, let's talk about what inequalities are. Inequalities are used to determine which of two numbers, I'm going to use the number symbol for numbers to shorten it up, is larger. When you look at a number line with 0 in the middle, and then we have our 1, our 2, our 3, we have our -1, our -2, our -3. Numbers on the left are going to be lesser, and numbers on the right are going to be greater. So left is lesser, we have L and L, and then right is greater. So it's easy to remember left is lesser they both start with L's. There's really not, right and greater both have G's, so I guess you could remember it that way if that clicks for you. But when you're looking at a number line, let's say we're looking at the number 1. 1 is greater than -1 because it's to the right of -1. If we look at -2, -2 is less than -1 because it's to the left of -1. So we have to have some symbols to be able to really show this and talk about this. I'm trying to get my paper straight, sorry about that. So here's our symbols. This symbol is greater than. I'll come over here. I'll go down here. And this symbol is lesser than. And then obviously we have equals to. So let's do an example so we can use these symbols, and I can show you a little trick with these symbols. So we have an example. We have 5. We need to put in a symbol compared to 0. So is 5 greater than, lesser than, or equals to 0? It's going to be greater than. 5 is to the right of 0. If you look at our number line, stick in a 0, 1, 2, 3, 4, 5. 5 and 0. 5 is to the right. So that means we need to put in greater than. So here's a helpful hint. The inequality symbol always eats the bigger number. So notice on our inequality how it opens up and it looks kind of like it's going to eat our 5. You know, if this is a face and we've drawn teeth, it's going to eat our number 5. 5 is bigger. It wants to eat the bigger number. So that's always going to be true. Let's show you another one. Let's do 4 compared to 8. Is 4 less than, greater than, or equal to 8? 4 is less than 8, so we're going to draw in our less than symbol. But again, notice this less than symbol is opening up or trying to eat the 8. So this always works. This is a really easy way to kind of remember which way to face your symbol. You're always going to have it opening up towards the larger number. Always opens up to larger number. Let's do, sorry, my paper is really crooked for some reason. There you go. Let's do a couple more examples. Let's look at -4 compared to -2, 1/2 compared to 1/4, and 3.4 compared to 5.16. Okay, so when you're dealing with negative numbers, remember the bigger the number actually means the smaller the value. So with negative numbers, the bigger the number, the smaller the value. And you can think of this in terms of like money that you owe somebody. If you owe them $4, that's more than if you owe them $2. So it's better to owe your friend $2 because then you're in debt less. So thinking of that is 4 less than or greater than -2. It's going to be less than. -4 is on the left of -2 on the number line. Is 1/2 bigger than 1/4? Fractions can be difficult if you're not used to thinking about them, so think about pi. If you have half a pi, is that more than 1/4 of a pi? Yeah, so this is the bigger number. So half is greater than 1/4. Is 3.4 greater than or less than 5.16? So you have $3.40. Is that less than or is that bigger than $5.16? It's going to be less than. Again, notice on all three of these examples, our inequality symbol is eating the bigger number. Okay, so that's inequalities. Let's move on to the second part of chapter 1.5, which is absolute values. Okay, so first let's define what an absolute value is. The absolute value of a number can be considered the distance between the number and 0. And this is going to look like a vertical bar, and then your number is in the middle, and then you're going to have another vertical bar. That's what an absolute value symbol looks like. So let's look at an example. We have the absolute value of 3, and so we need to know what does that equal. So let's look at a number line, and we have 0, 1, 2, 3. So we want to know how far away is 3 from the number 0. So we're starting here, and we're going to go back 1, 2, 3. We went back 3 spots, so the absolute value of 3 is 3. Let's look at another example. Let's look at the absolute value of -3. We'll draw a number line. And you don't always have to draw a number line. I'm doing this in the beginning so that you can kind of have some visual references. So we're going to start at -3, and we're going to go to 0. So we're going to go 1, 2, 3. The absolute value of -3 is 3. Because the distance between 3 and 0 is 3 spots, and the distance between -3 and 0 is 3 spots. So let's do a little note here. Note, if the number in the absolute value is positive, then the absolute value of that number is whatever that number it is. And we just saw that with the absolute value of 3. Absolute value of 3 was 3. And if you have an absolute value of a negative number, you're just dropping that negative, and that's going to be your answer. All right, so what if we have some negatives outside of our absolute value? What if we have something that looks like this, where we have negative the absolute value of a number? This is always going to equal negative whatever our number is. So let me write that. Note the negative. Oh, sorry, didn't mean for that to run off the screen. Let me pull that up. My screen's crooked. There you go. The negative of an absolute value is always negative. Which is what this says. We have negative absolute value of a number equals negative that number. So let me show you some examples so you understand exactly what that means. Example, let's have negative the absolute value of 4. Okay, so just looking at the absolute value of 4, we know that that equals 4 from above, just like our 3. So we still have this negative out front, so I'm just rewriting that. And the absolute value of 4 is 4. So if we have a negative times that, we will have a negative 4. Okay. Let's do another one. We have negative the absolute value of negative 5. You have to do what's in the absolute values first. Do the absolute values first. So we have to do the absolute values first. So this right here is going to become what? The absolute value of negative 5. It's going to become a 5. Just a plain Jane 5. So we still have that negative that's out front, and then we just have regular old 5. Again, negative times a positive 5 will give you a negative 5. So notice in each case we had a negative out front, and then it did not matter if we had a positive number or a negative number inside, because doing the absolute value of those gives you a positive number. So then you have a negative times a positive, which gives you a negative. Something that you might need a little bit of refreshing on is when you're multiplying by positive and negative numbers. So if you have a positive number, that's a plus symbol, so positive number plus or times a positive number, you will get a positive number. If you have a positive number times a negative number, you will get a negative number. If you have a negative number times a positive number, you will get a negative number. And if you have a negative number times a negative number, then you will get a positive number. So here's a little trick with those. If the two numbers you're multiplying have the same symbol, then they'll be positive. Then their product, let's write it that way, their product is positive. And that's what we just said over here. Notice the two, when you're multiplying two positive numbers together, you're going to get a positive number. If you multiply two negative numbers together, you're going to get a positive number. But the two in the middle, where the things are different, where you have one positive and one negative, we both get negative numbers out. So that's a nice little trick when you're doing that, and that's what happens up here. we have this negative out front times a positive number. So it's a negative times a positive right here, which says we have a negative output. That's really the end of the notes, so let's move on to do some of the homework. Okay, so now let's pull open the homework for section 1.5 and let's work a few of the problems. Okay. So I'm going to skip some of the earlier ones and try and find a few of the harder problems. Okay, this is a good problem to start with. It says insert either a lesser than or greater than in between the given numbers to make this statement true. We have 6 over 11, and then we have a space, and then we have negative 7 over 10. So what I recommend doing is I recommend putting those into your calculator. And if you put those into your calculator, you're going to figure out what each of those is. So if we put into our calculator, actually, scratch that. I say do that, and on most problems I would do that, but on this one I think we can skip that step. If you look at this number, we have a positive number, and then we have a negative number. Negative numbers are always to the left of positive numbers. So that means that we can just put in that this one is greater than that one. So which one of these are greater than? Simple over here. Remember, we always want to look at that. It even tells you if you leave your mouse over it. So you click that, hit enter, and we've got it. So that's one of them. Let's go on to another one. We did one just like that with our -3. Again, just like that. Really, these are just plug and chugs. Okay, this one might be a harder one if you're not used to working with decimals. Decimals are a little bit tricky, but if you think about it in terms of money, then you shouldn't have too hard of a problem. So this says we have 0.005 and we need to compare that to 0.006. So that means we have 5 1,000ths, and then we have 6 1,000ths. So which one of those do you think is going to be the bigger one? Let's try our 6 1,000ths because we have 6 of those, whereas over here we only have 5. So we're going to eat the bigger number, hit enter. Hey, we got it right. Good job. Let's see if we can find an absolute value problem. This is a good one. This isn't an absolute value problem, but this is a good problem because we have a negative times a negative. So you need to work that out before you can plug that number in. I'm not going to do that one for you. I have faith that you can get that one done. All right, here's an absolute value problem. We have 5, and we need to determine if that's greater than or less than the absolute value of -6. So you have to remember the absolute value of -6 is going to go to what? It's going to go to +6. So then we have to look, is 5 greater than or less than +6? 5 is less than +6. So we hit enter, and we did it. We got it right. That is all for section 5.1. Good luck on your homework, and good luck on your quizzes.